Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter Electrostatics. So any doubts, if you have in any steps, then please write that in the comments. Uh, Also please install our Sapience education application where we shall upload some important questions which shall be obviously helpful for your exam. So here it is told that 27 identical drops are charged at 22 volts each. They combine to form a bigger drop. The potential of the bigger drop will be. So there are 27 small drops and their radiuses are R. Since they are identical drops, so their radius will be R. They have the same charge also, Q. So then their potential, let's say V1, that is KQ by R, where K is for 1 by 4 pi epsilon naught. So Q by 4 pi epsilon naught R, that value is given as 22 volts. So then we have these 27 drops, they will combine to form a larger drop. Its radius is capital R. So the po po potential of the bigger drop will be. So the potential of the bigger drop, that is V, so that will be K capital Q by capital R, where the charge of the bigger drop is capital Q. So this is Q by 4 pi epsilon naught R. This value we have to find out. So now we can do the conservation of charge. So Q will be obviously equal to 27Q. And to find out the radius capital R, so we have to apply the conservation of mass. So there the density of the drops will be same only since they are identical drops. So the volume will remain the same. So the initial volume, that will be same as the final volume. So the volume, the initial volume, that will be 4 by 3 pi R cube into 27, since there are 27 drops. And the final volume, that is 4 by 3 pi capital R cube. So these two will be same. So therefore we can say R cube, that will be equal to 27 R cube. R will be equal to 3R. So therefore Q by 4 pi epsilon naught R, that value is Q is 27Q by 4 pi epsilon naught R is equal to 3R. It is 3 9s are 27. So this is 9 into Q by 9 times Q by 4 pi 9 times Q by 4 pi epsilon naught R. So Q by 4 pi epsilon naught R value is 22. So it will be 9 into 22. So this will be 9 to the 18. And 9 to the 18. So 198 volts. 198 is the answer. And here it is told a cube is placed inside an electric field. A cube is placed inside an electric field which is acting along the y-axis. So the electric field is 150 y square and it is acting along j cap. So the side of the cube is 0.5 meter and is placed in the field as shown in the given figure. The charge inside the cube is. So the flux will be non-zero. For the side faces, the flux will be 0 only, but for the base and for the top, the flux will not be 0. Since why for the base, the normal will be along, the n cap is along minus j cap, and for the top face, the normal vector is along j cap. So now this in the xy plane, in the xz plane, y value is 0. So here the electric field will be 0 also. So the only flux that will come, that is only along the top surface. So in the the base also, to the base of the cube also, there is no flux. Since we know that the net electric flux, that is equal to the charge enclosed by epsilon naught, which is called as the Gauss law. Gauss law of electrostatics. So now on the top face, the electric field will be on the top face, the electric field that will be 150 into, now this height is 0.5. So here the y value is 0.5. This is 150 into 0.5 whole square. So E dot area, the area is also 0.5 meter square. Therefore, the net electric flux to the top surface, the net electric flux to the cube is same as the flux through the top surface. The top surface. So that is 150. Simply it is E into A actually, E dot A. 150 into 0.5 whole square, 0.5 whole square. So this will be 150 into 1 by 4 into 1 by 4. So that is 1 by 16. This will be, so this much the electric field okay, 150 by 16. 150 by 16 is the flux, and so it will be Newton meter square per coulomb is the flux. And so charge enclosed that we find. So charge enclosed is epsilon naught into 150 by 16. So this will be epsilon naught, as you know, that is 1 by 4 by epsilon naught value, that is equal to or epsilon naught is 8.85, 4 into 10 power minus 12, 150 by 16. This will be 8.854 into is 83 approximately. So it is 83 into 10 power minus 12. So I can say it is 8.3 to 10 power minus 11 coulomb. Option B is the correct answer. And here it is told, choose the incorrect statement. The electric lines of force entering into a Gaussian surface provide negative flux. Yeah, so if it enters the Gaussian surface, then the n cap, the unit vector along the normal to the surface will be obviously outwards, and the electric field is coming inwards. So obviously the flux will be negative. There will be a negative flux. A charge q is placed at the center of the cube. A charge q is placed at the center of a cube. The flux through all the faces will be the same. It's placed flux through all the faces will be the same. Yeah, it is true. And the first one is also true. In a uniform electric field, net flux through a closed Gaussian surface containing no net charge is zero. Net electric flux through a closed Gaussian surface containing net charge is 0. Yeah, that is also true. So when electric field is parallel to Gaussian surface, it provides a finite non-zero flux. That is also that is false. Since why, if the electric flux is parallel to the Gaussian surface, then through the Gaussian surface, the normal vector is obviously perpendicular to the electric field. So it means the flux will be 0. The electric flux will be 0 in that case. So 4, the fourth statement is false. So 4 only. Option C is the correct answer. In a uniform field. So if there is a uniform electric field outside, then through a closed Gaussian surface which has no net electric field, the net flux will be 0 only. Since why, uh, net flux will come 0. Since the number of electric field lines that will enter the Gaussian surface, the same number of electric field lines will come out of the Gaussian surface. So hence the net flux will be 0 only in that case. So third one is true statement. Then here it is told two particles A and B having charges 20 microcoulomb and minus 5 microcoulomb respectively are held fixed with a separation of 5 centimeter at what position a third charged particle should be placed so that it does not experience a net electric force. At what position a third charged particle should be placed so that it does not experience a net electric force. So a third charged particle we should keep somewhere here. If we keep it here, then it will experience a net force. So we have to keep it somewhere here. Since if we keep it here, then this will attract and this will repel. Then it can come 0. Then the net force can come 0 here. So at what position a third charge should be placed so that it does not experience a net force? So let's say this distance is x, then this distance will be uh, this length will be 5 plus x centimeters. Then you can say that let's say its charge is q, so k into 5q, k q1 q2 by r square. That should be equal to k q1 q2 by 5 plus x whole square. This x we have to find out. So obviously we should keep it on the right side of minus 5 microcoulomb. So k and k will cancel out, q will cancel out. So 5 fours are 20. So then we can say 5 plus x whole square, that is equal to 4x square. So therefore now 5 5s are 25, 25 plus x square plus 5 are 10, 10x, that is equal to 4x square. So therefore I can say that 3x square minus 10x minus 25, that is equal to 0. So therefore x will be equal to minus b plus or minus square root of b square minus 4ac by 2a. So therefore x will be equal to 10 plus or minus square root of 100 plus 300 by 6. So x will be equal to 10 plus or minus, this is square root of 400, that is 20 by 6. So x will be equal to 30 by 6. Since why this x can't be negative, so 6 5 is 30. So we should keep at a distance of 5 centimeter from minus 5 microcoulomb on the right side. So option B is the correct answer. Then here it is told figure shows a chord AB which is bent in 120-degree circular arc of radius r. The charge minus q is uniformly distributed. The charge minus q, a charge minus q is uniformly distributed over the rod AB. It is having some net charge, it is minus q. What is the electric field E at the center of curvature O? How much is the electric field here? So here the thing is, if we take a K, so if we take a length, a small line element dq here, small line element dq here, then this is radius r. So then at this point, how much will be the electric field that we have to find? So here, this electric field will be like this. This is the electric field dE. Now here, let's say this angle is theta. Now we have to take the component. Now this is theta, then this will be theta also. So now this will have one component dE, which is along the y-axis, that is d e sine theta, and this is dE cos theta. Now dE sine theta components will get cancelled, since why? Since corresponding to this dq charge, here also we can have a similar dq charge, and whose electric field will be like this. So then that dE sine theta component will get cancelled. So only dE cos theta components we have to integrate, and the net electric field will be along the negative x-axis. So it will be along the positive x-axis, since why? The charge is negative. So it means that this diagram is you have drawn, that is not correct. Say that uh, let's say we take a dq component. We take a dq component here, and then this is having negative charge. Now the net negative charge is minus q. So therefore lambda, we can say lambda is the charge per unit length, or the linear charge density, linear charge density. So that is equal to minus q by the net length. That will be obviously, so you can tell r into theta. Theta is 120 degree by 360 degree. So 120 degree we have to convert into radians. It's pi by 180. So this will be 0, 0, 6 to the 12, 6 is 18. So it is 2 pi r by 3. Pi r by 3. This is the length L. 2 pi r by 3. So this is minus 3q by 2 pi r. And which is also equal to dq by dl. Since it is having length dl, so this is equal to lambda dl. This lambda r d theta I can tell. This angle is d theta at an angle theta we are saying. Now this electric field will be obviously not like this. It will be like this, since why it is having negative charge. So it will have components. One is along x-axis, which is dE cos theta, and along y-axis the component will be dE sin theta. Now dE sin theta components, as I told, that will get cancelled out. Only dE cos theta components will remain. So therefore the net electric field will be obviously integral dE cos theta. It will be along I cap, obviously. And this d cos theta component here, d cos theta d theta, I should tell. D cos theta, sorry, no, not, will not be there. Now dE cos theta I cap, and theta will go from, obviously, from minus 60 degrees. So 60 degree, as you know, 60 degree means it is 60 into 2 pi by 180 radians. 6 3 is 18, so pi by 3 radians. So it will go from minus pi by 3 to pi by 3 to plus pi by 3. And dE we can say dE will be equal to kq by r, that is k dq by r. K dq by r, which is k into dq, that is lambda r d theta by r square actually. Kq by r square. R will cancel, so this is lambda d theta by 4 pi epsilon naught r. Lambda d theta by 4 pi epsilon naught r. So this is minus pi by 3 to plus pi by 3. Lambda by 4 pi epsilon naught r cos theta d theta I cap. So therefore the net electric field, that will be equal to lambda by 4 pi epsilon naught r integral cos theta d theta from minus pi by 3 to plus pi by 3. Now integral cos theta, that is obviously integral cos theta is sin theta. So sin theta will go from minus pi by 3 to plus pi by 3. So this will be lambda by 4 pi epsilon naught r into sin pi by 3 minus of minus sin pi by 3. So that is 2 sin pi by 3. So sin pi by 3 means sin 60 degree. Sin 60 is root 3 by 2. So this will be root 3. So this is lambda by 4 pi epsilon naught r into 2 into root 3 by 2. That is 2 will cancel. So Therefore, the net electric field that is actually along I cap, that is root 3 lambda by 4 pi epsilon naught r. Lambda by 4 pi epsilon naught r, which is root 3 by 4 pi epsilon naught r into lambda. Lambda, that is 3q by 2 pi r. 3q by 2 pi r. 3 root 3q by 2 4 so to the 8 pi square epsilon naught r square. 8 pi square epsilon naught r square. 3 root 3q by 8 pi square epsilon r square. By 8 pi square epsilon naught r square. Yeah. So it is 3 root 3q by 8 pi square epsilon naught r square I cap. So option B is the correct answer. And here it is told a uniform charged disk of radius r having surface charge density sigma is placed in the xy plane with its center at the origin. Find the electric field intensity along the z-axis at a distance z from the origin. Let's see, if I take, this is the x-axis, this is the y-axis, and so this will be the z-axis. So the disk is placed here only. So now if we consider the disk like this, then we can consider one small ring. We can take it as an element. We can take it as the element. It is having charge dq. The net charge is q. The net charge is q, which is sigma into pi r square. The surface charge density, that is uniform. Now at a distance z, here how much will be the electric field? That is, let's say here this point, this will be dE, the ring. So dq, I can say that is equal to sigma into 2 pi, its radius is small r, pi r dr, and this r will obviously go from 0 to r. So for a ring, if we have a ring having charge q, that I can say lambda into 2 pi r. Suppose its radius is r. Then at a distance x from it, how much will be the net electric field? So that will be, here we have to take dE, then we have integrated this as theta, so then this will be dE cos theta and dE sin theta. dE sin theta components will get cancelled out, so only dE cos theta we have to integrate. So integral dE cos theta, that is the net electric field due to the ring. Now that is given as now dE, I can say that will be actually x dq. So this is dq k dq by kq by r square. So this is r square will be r square plus x square. Now dq that we have to integrate. So this will come k q by r square plus x square into cos theta. Cos theta will be obviously x by this square root of x square plus x square. So this is kqx by r square plus x square power 3 by 2. So here also this dE due to this ring, that will be equal to k dq into z, k dq into z by uh, r square plus z square power 3 by 2. The dE, now we have to integrate this throughout the ring. Therefore here dE that is equal to kz by r square plus z square power 3 by 2. Here dq that is sigma into 2 pi r dr. So it means that this r is changing. So therefore the net electric field due to this uniformly charged circular disk, the electric field due to this uniformly charged circular disk we have to find. So E will be integral of this dE, and that the electric field will be obviously along x-axis. E will be integral of dE. That is integral of kz sigma into 2 pi r dr by r square plus z square power 3 by 2. So now r will obviously go from 0 to r. So this will be now z is a constant here. Z is constant obviously. So k into 2 pi, it means k into 2 pi if you do, that is actually 2 pi by 4 pi epsilon naught. So that is equal to 1 by 2 epsilon naught. So this is um, sigma z by 2 epsilon naught, z by 2 epsilon naught into integral r dr by r square plus z square 3 by 2 is from 0 to r. This you have to integrate now. Now r dr, if you take this r square plus z square, if I take it as t square, as t square suppose, so then I can say 2r dr, that is equal to 2t dt, since z is a constant. So r dr is t dt, and then t square, that so t will go from, so r is going from 0 to r, So now t, that will go from root t is z. T is actually root over r square plus z square. So t will go from z to root over r square plus z square. So therefore I can say sigma z by epsilon naught and integral t dt by, so t square power 3 by 2 is t cube, and that will go from z to root over r square plus z square. So this will be 1 by t square. So this will be sigma z by 2 epsilon naught into t power minus 2. This will be, so t power minus 2 plus 1 by minus 2 plus 1. Will go from z over r square plus z square. So this will be sigma z by uh, minus sigma z by 2 epsilon naught, and this will be 1 by t power minus 1 means 1 by t. So 1 by root over r square plus z square and minus 1 by z. Or I can say this will be sigma by 2 epsilon naught. So this will be 1. So this will be 1 minus z by root over r square plus z square. Sigma by 2 epsilon naught. Sigma by 2 epsilon naught into 1 minus z by r square plus z square power half. Yeah. So it means that option A is the correct answer. And here it is told the two thin coaxial rings each of radius A, two thin coaxial rings of each of radius A, two thin coaxial rings, um, two thin coaxial rings each of radius A, having charges plus q and minus q respectively, are separated by a distance s. The potential difference between the centers of the two rings. So they each are having the same radius. So the figure should be actually like this. One ring is placed like this, and their axis is the same. They are placed coaxially. Their radiuses are same. Radius is a, each having radius a only, and they are being separated by a distance s, and they are having charges plus q and minus q respectively. The potential difference between the centers of the two rings. We have to find the potential difference in between the centers of the two rings. So here, let's call it as point A, point B. So we have to find out VA minus VB. Actually, it's mod. So now VA, the VA means the potential at the point A. So that will be obviously KQ by R, or this. mm, by R. This will be KQ by A. Then this will be K into minus Q by KQ by this length. This length will be obviously root over A square plus S square. Minus Q by root over S square plus A square. And VB, the potential at the point B, that will be obviously K into minus Q by A plus KQ by this. From here, this will be obviously A square plus S square. So root over S square plus A square. So therefore now V A minus VB, that will be obviously K 2KQ by A. Then minus this will be minus 2KQ by root over A square plus A square. Therefore, I can say this will be, so this will be 2K means Q 1 by 2 pi epsilon naught. So this I can write Q by 2 pi epsilon naught into 1 by A minus 1 by S root over S square plus A square. 2 by 2 pi epsilon naught minus into 1 by A minus 1 by root over S square plus A square. So option D is the correct answer. Here it is told a solid metal sphere of radius r, solid metal sphere having of radius r having charge q is enclosed. It is having charge q. Charge q is enclosed inside the concentric spherical shell. Inside the concentric spherical shell of the radius a and outer radius b, as shown, the approximate radiation of the electric field E as a function of approximate variation of the electric field as function of distance r from center O is given by. Set the concentric spherical shell of inner radius SB. Okay. It is a metal sphere. So it means that inside there is no electric field from 0 to r. There will be no electric field. And then from here to here, suddenly there will be electric field which is KQ by r. So that is 1 by r variation. A to B, again, it is a metallic, that is a spherical shell. It is a conductor, I can say. So there will be no electric field. Here to here, there will be electric field. The net charge will be here, be plus, and here there will be some induced charge here. And then this net charge will come outside also. Outside again, there will be electric field. From A to B, there will be electric field, and then again there will be 1 by r variation. So option A is the correct answer. Option A shows the correct variation of the electric field as a function of the distance r from the center O. Then here it is told what will be the magnitude of electric field at point O as shown in the figure. The magnitude of the electric field at point O as shown in the figure. Each side of the figure is length L and perpendicular to each other. What will be the electric field here? So all these are charged uh, linear nodes, I can say. So if we have a rod, then at some point is here, how much will be the net electric field if we want to find that? Then that will be here if we want to find the electric field. So then this point here, this will be, will come like this. This is having length L, having charge, let's say capital Q, having positive charge. Then we will take a small line element dq here. Dq will be equal to lambda times dl. Then this will be right. So this is theta 1, this is theta 2, this is theta suppose. So then this will be for dq. Here we will have d. It will have some x component, which is, this is theta, so this will be theta also. So this will be dE cos theta, this will be dE sin theta. It will have x component of the electric field and y component of the electric field. So Ex, that will be integral E cos theta. Here theta is going from theta 1 to theta 2. And the electric field along the y-axis, that will be integral dE sin theta. And that will go from theta 1 to theta 2. And dE, I can say dE will be equal to lambda dl. So it is k dq by r square. R square, I can say, suppose this is, suppose if I tell this is r, then I can say this length is L. This length, if it is capital R, r cos theta, that is equal to r. So r will be equal to r by cos theta. That is r by cos theta whole square. So this is lambda dl. dq, I can say this is metal, this is y. Now y is r sin theta. dy I can say. dq is dy. It means lambda dy. dq is lambda dy. So it is a into lambda dy. Y is r sine theta. So dy that will be equal to r cos theta d theta. It is r cos theta d theta by r by cos theta. So this is r square into cos square theta. So d that is equal to lambda r by 4 pi epsilon naught r square into cos cube theta d theta. Yeah, so suppose if we take uniform line charts, then if we take a point at a distance r from this uniform line charge, suppose it is having charge q, then we will take a line element dq here. So then here we will have the electric field. This will be let's say it is going from theta 1 to theta 2, from minus theta 1 to plus theta 2. So then this way it will be the d, the small electric field. Now this is at an angle theta, so then this will be also theta. So this is de cos theta and this is de sin theta. Therefore, the net electric field along the x-axis, that will be the integral of de cos theta, and where theta is going from minus theta 1 to plus theta 2. And then the y component of the electric field will be integral of de sin theta, where theta is going from minus theta 1 to plus theta 2. Therefore now E will be obviously k dq by this length. Let's say this is L. L will be obviously R by cos theta. L cos theta is R, so R sec theta. And then if this is Y, then we can say dq that will be obviously equal to lambda into dy, where lambda is q by L. So q by L, this is the length, q by L into dy. So lambda dy, lambda dl. Okay, lambda dy actually we should tell, lambda dy. Okay. Now y we can say this is equal to r tan theta, since y by r is tan theta, so y is r tan theta. So therefore dy that will be equal to r secant square theta d theta, since d by d theta of tan theta is secant square theta. So this will be lambda r sec square theta d theta. And similarly this will be k dq by L square. So this will be k 1 by 4 pi epsilon naught, and dy dq, that is lambda r secant square theta d theta divided by 4 pi epsilon naught into L square. L square will be r square secant square theta. Secant square theta will cancel. So this will be r will cancel. So this will be lambda d theta by 4 pi epsilon naught r. Now, therefore, the x component of the electric field that will be equal to integral minus theta 1 to plus theta 2. So dE, that is lambda. So this will be cos theta d theta by 4 pi epsilon naught r. So it will be lambda by 4 pi epsilon naught r into cos theta d theta integral is sin theta. So sin theta, that will go from minus theta 1 to plus theta 2. So this will be lambda by 4 pi epsilon naught r into to sin theta 2 plus sin theta 1. Sin theta 1 plus sin theta 2. And therefore, the y component of the electric field, that will be integral dE sin theta. So this will be lambda sin theta d theta by 4 pi epsilon naught r from minus theta 1 to theta 2. So now this will be lambda by 4 pi epsilon naught r integral sin theta d theta, and integral sin theta is minus cos theta. So this will be minus lambda by 4 pi epsilon naught r. So this will be cos theta 2 minus cos theta 1. So this will be lambda by 4 pi epsilon naught r into cos theta 1 minus cos theta 2. So now here we can see that if we have a point, suppose like this, then here how much will be the electric field at this point P. Now here r is 0. R is 0 and theta 1 and theta 2 both are theta 1 is 0 degree, theta 1 is 0 degree, and theta 2 is 90 degrees. We take this point. Or we can say that theta 1, yeah, theta 2, it is here, so theta 1 is 0 degree. So x component will be, but here r is 0 only. So there will be no electric field. So it means here if you have to find the electric field at the point O, then for these parts there will be no electric fields, but for these parts there will be obviously electric field. For this part, this will be is now theta 1, that is 0 degree, and theta 2 is 90 degree. No, theta 2 is not 90. Theta 2 is, this is L, this is L. So theta 2 is 45 degrees. For this also theta 2 is 45 degrees. This also theta 2 is 45 degrees. For this one also theta 2 is 45. This is also theta 2 is 45 degrees. Okay, so therefore the x component of the electric field, therefore the x component of the electric field, that will be obviously equal to x component of the electric field, that is lambda by 4 pi epsilon naught r into 5. So sine 45 is 1 by root 2. So 1 by root 2. K lambda by root 2r, I can say. Y also, that will be theta 1 is 0, theta 2 is 45. This is minus 1 by root. Therefore, Ey will be minus K lambda by root 2r. So it is along the negative y-axis. That's why. So this way it will be. So let's say I call it k lambda by root 2 r as e naught. So this will be minus e naught. This will be e naught. So this will be e naught like this, and for this one, this will be also e naught, and for this part also, this will be e naught. This will be e naught, and no, the thing is that this is having negative charge. This is having negative charge. So this will be attractive. So this will be attractive electric field. Lambda is negative here. Sorry. So this is E naught and this will be E naught for this, and this way it will, for this one it will be here lambda we are saying that is Q by L. So it means 2Q by L, that will be obviously 2 lambda. For this one, this will be repulsive. So this is E naught and this way E naught. So E naught plus E naught. So 2 E naught. For this one again, this one is minus Q. So this way it will be E naught. This way it will be E naught. So E naught plus E naught here. And for this one again, this is 2Q. So this will be 2 E naught. And it is repulsive. So it will be E naught plus 2 E naught here. And this way it will be 2 E naught plus 2 E naught here. E naught and 2 E naught will get cancelled. This 2 E naught and 2 E naught will get cancelled. So like this E naught and like this E naught. So E naught and E naught. So therefore the resultant, the magnitude of the net electric field will be root 2 E naught, root 2 E naught, where E naught is K lambda by root 2 R. So K lambda by root 2 R. So therefore the net electric field at the point O, that will be root 2 E naught is into K lambda by root 2 R. Root 2 will cancel, so this will be lambda. Now here R is obviously equal to L. R is equal to L only. So lambda, so now lambda is Q by L. So Q by L by 4 pi epsilon naught into L. So this will be Q by 4 pi epsilon naught L square. Q by 4 pi epsilon naught L square. So option A is the correct answer. And here it is told that two identical tennis balls, each having mass m and charge q, are suspended from a fixed point by threads of length L. Two identical tennis balls, each having mass m and charge q, are suspended fixed point they are suspended from a fixed point by threads of length L, then what is the equilibrium separation when each thread makes a small angle theta with the vertical? Is their equilibrium separation, that is R. Each thread makes a small angle theta with the vertical. This equilibrium separation we have to find out. So now here there is a tension force here. Here also the tension force will be same since these two are symmetric by symmetry, I can say. Now this will be the electrostatic force of of repulsion, and this is the electrostatic force of repulsion. The electrostatic force of repulsion, and this is mg, obviously the weight. This is the tension. Now this will be theta, so this will be t cos theta, and this will be t sin theta. So therefore t sin theta, that is equal to the force, that is equal to k q1 q2 k q square by r square. T cos theta, that is equal to cos theta, that is equal to mg. Equilibrium separation, that x, they are calling this as x, so x we have to find out. This is x square. So now so this x by 2, this is x by 2. So I can say this is x by 2. X by 2 will be equal to L sin theta. Now if we divide this, then we will get tan theta, that is equal to kq square by x square mg. So this is x by 2L, that is sin theta. So therefore tan theta will be equal to sin theta by cos theta. So this is x by 2L by square root of 1 minus sin square theta. Square root of 1 minus x square by 4L square. So this will be x by 4L square minus x square. Tan theta. Now this is also tan theta. So it's L sin theta. So therefore you can say x by root over 4L square minus x square. That is equal to kq square by x square mg. Now if we square both sides, then we'll get x square by 4L square minus x square, that is equal to k square Okay, this is q square by 16 pi square epsilon naught square 4 by epsilon naught x power 4 mg m square g square. This will be sine theta, we can say that is tan theta by okay. Power 4 this will be. Now we can simplify it. So this will be x power 6 into 16 pi square epsilon naught square m square g square. That is equal to q power 4 into 4l square minus x square q power 4. So x power 6 into 16 pi square epsilon naught square m square g square plus x square q power 4 minus 4l square q power 4, that is equal to 0. Now it is a cubic equation in x square. X I can write 12 sine theta. So 4l square. Can do this like this also. T sine theta, that is equal to kq square by x square, which is x by 2 is L sine theta. So x is 2L sine theta. So 4L square sine square theta. T cos theta, that is equal to mg. Means T I can write mg by cos theta. Therefore mg into tan theta, that is equal to kq square by 4L square sine square theta. Now sin square theta I can write 1 minus cos square theta. Means we can say therefore this mg into tan theta g tan theta, that is equal to mg into tan theta, that is equal to kq square by 4l square sine square theta. That means that tan theta into sine square theta, that is equal to kq square by 4l square mg. And theta into sine square theta, this is q square by 4 pi epsilon naught, so 16 pi epsilon naught l square mg. Now sine theta by cos theta, so sine cube theta by cos theta, that is this q square by pi square pi epsilon naught l square g. So l square sine square theta, l square 4l square sine square theta, that is obviously x square. Means that 4l square sine square theta will be obviously q square by pi epsilon naught mg tan theta. So it means x square is actually q square by 4 pi epsilon naught mg tan theta. Q square now tan theta is very small. Tan theta is approximately equal to theta only. Theta. So tan theta is approximately equal to theta approximately equal to sine theta, since here it is told that it is a small angle, so we can use small angle approximation. So now sine theta is x by 12, sine theta is x by 12, so it means that theta also will be x by 12. So theta is also approximately x by 12, which is also equal to approximately same as tan theta only. So x by 12 I can say. So theta is, this is x by 12. So it means that I can say 2 2s are 4. So this will be x cube. X cube will be equal to q square by q square L by 2 pi epsilon naught mg. So therefore x will be approximately, so this is approximately q square L by 2 pi epsilon naught mg whole power 1 by 3, means it is the cube root of this. Square L by 2 pi epsilon naught mg whole power 1 by 3. So option B is the correct answer. Then here it is told two ideal electric dipoles A and B having their dipole moment P1 and P2 respectively are placed on a plane with their centers at O as shown in the figure at point C on the axis of dipole A. On the axis of dipole A, the resultant electric field is making an angle 37 degree with the axis. The ratio of the dipole moment of A and B, that is P1 by P2, is okay. So here, so this is the dipole moment P1, this is the dipole moment P2. Now this point at the point C, it is placed on the equatorial plane for P2 and on the axis for P1. So here it will have electric field. This is obviously, say this length, this is R obviously, suppose. So this electric field E1 due to the dipole moment P1, so that will be 2k P1 by R cube, and which is along the x-axis, obviously along I cap. And for this one, this will be opposite. This E2, that will be equal to minus kp by R cube, that is kp2 by R cube, and along J cap it will be. So therefore the resultant that is E net, that is making an angle 37 degree with the axis. So therefore it means that E net, let's say as E net cos 37, that is equal to E1, and E net sine 37, that is equal to E2. So therefore I can say that tan 37, that is equal to tan 37, that is equal to E2 by E1. Tan 37, as you know, 3, it is 3 by 4. Cos 37, that will be obviously root over 1 minus sine square 37, 1 minus 9 by 25, that is 6 over 16 by 25, that is 4 by 5. So it means tan 37 is 3 by 4. Tan 37 is 3 by 4. So 3 by 4 is equal to E2 by E1. So therefore E1 by E2, that is obviously equal to 4 by 3. Now E1 is equal to 2 kp by R cube. So therefore we can say E1, that is 2k P1 by R cube divided by E2, that is kp2 by R cube, kp2 by R cube, that is equal to 4 by 3. So therefore this k by R cube part will cancel out. So 2 P1 by P2, that is equal to 4 by 3. So it means P1 by P2, that is equal to 2 by 3. P1 by P2 is 2 by 3. So option C is the correct answer. And here it is told the electric dipole is placed on x-axis. An electric dipole is placed on x-axis. Electric dipole is placed on x-axis. Let's say P1 x-axis in proximity to a line charge of linear density, this lambda, that is 3 into 10 power minus 6 coulomb per meter. Line charge is placed on z-axis, x, y, and z. Line charge is placed along z-axis, lambda. Now, and positive and negative charge of dipole is at a distance of 10 millimeter and 12 millimeter from the origin respectively. The negative charge is at 10 millimeter and the positive charge is at 12 millimeter from the origin respectively. If total force on 4 Newton is exerted on the dipole, the total force here, this will be attractive, this will be repulsive, so the net will be attractive. So the net force, that is 4 Newton, is exerted on the dipole. Find the amount of positive or negative charge of the dipole. Let's say it is plus q, this is minus q. So now the electric field due to a long line charge, that is 2k lambda by r. Electric field that is given as 2k lambda by r, which is lambda by 2 by epsilon naught r. Now, therefore, the net force that will be exerted, that is One is on the positive charge that will be repulsive, on the negative charge that will be attractive. So this will be lambda by 2 pi epsilon naught into QE, that is, so lambda Q by 2 pi epsilon naught into 1 by R1 minus 1 by R2. Q I have to find out. Q I have to find out. This is 4 Newton, it has been told. And R1 is 10 millimeters, so it is 10 into 10 power minus 3 meter, means 10 power minus 2 meter. And R2, that is 12 millimeters, so it is 12 into 10 power minus 3, or I can say 1.2 into 10 power minus 2 meter. So lambda, that is 3 into 10 power minus 6 into Q divided by 2 pi 2 into 3.14 into epsilon naught. Actually 1 by 4 pi epsilon naught is 9 into 10 power 9. So 1 by 2 pi epsilon naught means twice of this. So 18 into 10 power 9. This will be, instead I can write this will be lambda, which is 3 into 10 power minus 6 into Q into this will be 18 into 10 power 9 into this will be 1 by 10 power minus 2 minus 1 by 1.2 into 10 power minus 2 equals to 4. Then Q I have to find out. So this will be 18 3s are 54, 54 into 10 power 3. This will go up, so this will become 10 power 2. This will be 1 minus 1 by 1.2. So this will be equal to 4 into Q. So therefore, this will be Q into this will be 1.2 minus 1, so 0.2. Q into 0.2 by 1.2 into 54 into 10 power 5 equal to 4. So 2 6 are 12. 6 9s are 54. So Q will be equal to 4 by 9 into 10 power minus 5 coulomb. So Q will be equal to 4 by 9, it means it is 0.44444 10 power minus 5 coulomb, or I can say it is 4.44 microcoulomb. So it means that option D is the correct answer. And here it is told a certain charge Q is divided into two parts, Q and Q minus Q. How should the charges Q and Q and Q be divided so that Q and Q minus Q placed at a certain distance apart experience maximum electrostatic repulsion? So here it is charge Q is placed, here Q minus Q charge is placed. So here it is told that if I keep at some r distance apart, then the maximum electrostatic repulsion they has to experience. So by Newton's third law, both of them will experience the same magnitude of the force. So that force will be equal to K into Q minus Q, K Q1 Q2 by R square. So this should be maximized. It means dF by dQ that should be equal to 0, and d square F by dF square that should be negative. Then only we will have maximum repulsion, since this is called the condition for maximum of a function. Since here F, this force is a function of this Q, condition for maxima. So therefore, I'll say that d by dq of Q into Q minus Q, that should be equal to 0. So it means that Q Q minus this is Q square, so this will be 2Q, that is equal to 0. So Q should be equal to Q by 2. So Q should be equal to 2Q. So it means that capital Q should be equal to twice of small q. So Q should be equal to 2Q. So option A is the correct answer. Then it is told an oil drop of radius 2 millimeter with a density 3 gram per centimeter cube is held stationary. Its radius is 2 millimeter. Its density rho, that is 3 gram per centimeter cube. It is held stationary under a constant electric field. So here we have a constant electric. So then what is the number of excess electrons? So it will experience a force that is upwards, and it is having mg downward. So it is held stationary. It means the electric force that should be equal to the weight, that should be equal and opposite to the weight. And it is having x. What is the number of excess electrons that the oil drop will uh, possess? So let's say it is having n number of excess electrons in it, n number of excess electrons in it. So therefore it will have a net charge q will be equal to Ne, and since the electric field should be acting vertically downwards, so the force that is equal to q times E, that should be upwards. So q times E, that should be equal to mg. Now q is equal to Ne, so Ne into E, that is equal to mg. So n we have to find out, n will be equal to mg by E into E. So mg, so mass of the oil drop, mass will be equal to density into volume, which is 4 by 3 pi r cube. So it is density into 4 by 3 pi r cube to g divided by E into E. So therefore the number of excess electrons in it, that will be 4 into rho, that is 3 gram per centimeter cube, 3 into 10 power minus 3 3 into 10 power minus 3 kg cube. So this will be 10 power minus 6 meter cube. So 1 centimeter cube, I can say this will be 10 power minus 6 meter cube. So this will be 3 into 10 power 3 kg per meter cube. So 4 into 3 into 10 power 3, this pi is 3.14 into r cube. R is 2 millimeter, so it is 2 into 10 power minus 3 meter. So 2 into 10 power minus 3 meter, its whole cube, into g is 9.81 divided by 3 into E. E is the charge of the electron, which is 1.6 into 10 power minus 19 coulomb, into E. E is the electric field, that is 3.55 into 10 power 5. Okay, so now if we solve it, this will be, the 3 will cancel. Now this will be, therefore n, that is equal to 4 into 3. Okay, 4 into 3.14. The 8 into 9.81 into this will be 10 power 3 into this will be 10 power minus 9. This is a 9 divided by 1.6 into 3.55 into this will be 10 power minus 19 into 10 power 5. And power 5. So this will be um, 4 to 32 pi into 9.81 divided by 1.6 into 3.55 into this will be 10 power 19 minus 9 is 10 power 10 plus 5, that is 10 power 15 plus 3 or 18. So this will be, so it is of the order of 10 power 18. Now this is 10 power 19 plus 3 minus 9 minus 5. So this will be 32 pi. Okay, 32 pi into 981 by 1.6 into 355 into 10 power. This will be 10 13 minus 5, that is 8 power 8. So this will be 32 into pi into pi to, this is approximately 173.63 into 10 power 8 excess electrons. So it is 1.736 approx into 10 power 10 electrons, excess electrons. 1.73 to 10 power 10. So option B is the correct answer. Then here it is told, find out the surface charge density at the intersection. Find out the surface charge density at the intersection of point x equal to 3 meter plane. At the intersection of the x equal to 3 meter plane and x-axis in the region of uniform line charge of 8 nanocoulomb per meter lying along this z-axis in free space. Region of uniform line charge along the z-axis. Suppose this is x-axis, this is y-axis, this is z-axis. Now uniform line charge is there. Lambda is 8 nanocoulomb per meter lying along the z-axis, and surface charge density at the intersection point x equal to 3 meter plane, x equal to 3 plane, which will be obviously parallel to the yz plane and which will intersect the x-axis at x at 3 comma 0 comma 0. And here surface charge density that we have to find out. The intersection of x equal to 3 meter plane and x-axis. The region of uniform line charge here there will be an induced charge formed. This plane now here the electric field due to this wire that should be same as the electric field due to this plane charge. Let's call it as an infinite plane sheet. So here this will be 2k lambda by x. If we call this is x, that should be same as sigma by 2 epsilon naught. Sigma by epsilon naught, since here there will be some induced charge here and here also some induced charge will be formed. Okay. So therefore 2k lambda 2 into lambda by 4 pi. Okay. So 2 into k, that is 9 into 10 power 9 into lambda, that is 8 into 10 power minus 9 coulomb per meter, divided by x is 3, and that is equal to sigma that we have to find out. Sigma we have to find out, sigma by epsilon naught. Okay. So sigma will be, this will be 3 3s are 9, so 2 3 are 6, 6 8s are 48, 48 into this 10 power 9, 10 power minus 9, that will cancel out. So 48 into epsilon naught. So sigma will be 48 into epsilon naught, that is 8.854 into 10 power minus 12 coulomb per meter square. So this will be now, so 48 so 48 into this will be approximately 424. It's 48 into 9. If you do 9 8 is 72 and 36. 433, 432. So it is approximately 424 into 10 power minus 12 coulomb per meter square, or I can say this will be 0.424 nanocoulomb per meter square. So option A is the correct answer. So hope all of you understood all these solutions based on the previous year JEE Mains exam. Still any doubts if you have, please write that in the comments section. And please install our Sapience Education application, which shall be obviously helpful for our exam.